So now let's talk about I said there's 4 different options. So the first one we did was strong acid, strong base. So now we want to do the second one. So now we'll make one strong, one weak. So the first one we want to do is say the base is strong and the acid is weak. This is going to be a lot more complex, okay? So we really like when they're both strong. When I start making one weak and one strong, it gets more complex. And if they're both weak, then it's like super complex, okay? So let's get a little bit more challenging. So here I've got a weak acid with my strong base. These are on your chart, okay? They're gonna form my salt and water, just like we know. Now, weak acids, when they are in the water, in the solution, they only partially ionize. They don't completely separate. So whenever I write my complete ionic equation, I do not dissociate the acid on the reactant side. Okay? So even though he's aqueous, because he's weak, I write him out. He's strong, he's aqueous, and he's strong, so I separate him to Na plus and OH minus. He's aqueous, and he's a salt, so I always separate salts. Ooh, I messed that up. I forgot to write my arrow. Make sure you go back and do that. Plus Na plus aqueous and water. All right, so don't separate this guy because he's weak. He's strong, separate him. He's a salt, separate him. He's a liquid, don't separate him. So now we need the net ionic. So what's on the same on both sides? And that's it. That's the only spectator. He's the only one on the same on both sides. So what we get left is my acid plus my base ion goes to my acid conjugate plus water. All right, so let's look at that. So that's all that's left. So that's the only stuff that can react. So this is the only stuff that can react. What's going to happen? Okay, so we said this was a weak acid. Okay, weak acid. This comes from my strong base. It's part of my strong base. So if this is the weak acid, his partner is the base. So here's my acid. Here's his conjugate base. If he's a weak acid, conjugate would be a strong base. He's a strong base. The conjugate is a weak acid. So what happens is that my acetic acid here is going to form an acetate ion. So here's my acetate ion, okay? My acetate ion is going to end up being stronger than my acid. Now I wrote strong base, but when we talk about strong, we're just saying stronger. Like, it's not like a super strong base, okay? All right, now, so this is what I mean by this. Like, it's stronger than my water. I'm doing a comparison. So what happens, though, is I know when I'm trying to figure out is it going to be more basic or acidic? So I have to figure out of the products who's stronger. So water is neutral, and if he's basic at all, then he's going to be stronger than him. So what that means is my solution is basic, and so my pH is going to be greater than 7. Okay? That's all you have to know. Okay? So here's kind of your hint. If I have strong base, weak acid, so the stronger guy is going to overcome kind of the weak acid, and so whoever's stronger, he's going to have some of him left. That's how you can kind of think about it. So strong base overwhelms all the weak acid, so we got a little bit of base left over, and so that's why the solution is going to be basic. That's not like the scientific explanation, because this is the scientific one. But that's how you can kind of think about it. Now, a side thing that could happen is that these two could continue to react. They could keep going and keep reacting. If they decide to keep reacting, it's going to break down this water. And if I break down that water, it's called a hydrolysis. reaction. And so this is where water is broken apart. And if I do that, I get OH minus ions, which is the sign of it being basic. So even if it does do this, it's still leading to being a basic solution. So I don't have to worry about it that much. All right, so let's look at a problem. Because if it's just strong acid, strong base, we don't even have to do any math. If it's strong, it's automatically 7. But if it's weak and strong, I know that since the base is strong, it's going to be basic. And I know the pH is going to be bigger than 7. But what if I want to know what the actual number is? And I want to be specific on what that number is versus just knowing it's greater than 7. So let's look at a problem. Well, first let's look at this. So it says for a weak acid and a strong base, the pH depends on Kb. So how high is the pH going to be? Like we know it's going to be bigger than 7, but by how much? So the larger the Kb, remember we said this, the stronger the base. So the bigger the Kb, the higher the number, the stronger the pH. Okay? All right, so look at this problem. What is the pH of 1.5 molar Na2CO3 aqueous? And they gave me the Kb, and then here's something that's different. So the hard part with this for some people is to recognize that this is a salt. So I'm asking you, what is the pH of this salt solution? And a lot of people are like, how do I know that's a salt versus a base or an acid or whatever? So first they gave me Kb. So now if they give me Kb, I should be thinking I'm in the basic realm. Well then how do I know that this is a salt? Here's your hint. They give you this guy in parentheses. Let's look at our other problems that we've done. Like this one. When they gave me the Kb right here, did I have anything in parentheses? No. This was telling me that the Kb is just for a straight up base, which is for this guy. This is telling me that the Kb is for this part of my salt. Okay? So if you ever see something in parentheses after the K, it could be Ka or Kb, and we're going to go through if it's Ka in the next lecture. So if it's Kb, then it's giving me a hint and telling me it's breaking this down into a salt. So let's talk about how it's breaking it down. So if I break this down to my ions, I have Na plus and I have CO3 2 minus. So if I wanted to make compounds with that, I can add either an anion here and a cation here. What I want to add would be the acid and bases. So acids have H plus, bases have OH minus. So he would want the OH minus, he would want the H plus. When I add that, I get NaOH, and he's H2CO3 because you write H plus because you go put him first and cross down your charges. So then we want to look on the chart. This guy is a strong base. This guy is a weak acid. What did we say? If it's a strong base, a weak acid, I know that my answer, my solution is going to be basic. Okay, so my solution is going to be basic. Now remember that the ion we get is the conjugate of this. If this is the weak acid, if this is the acid, its conjugate is the base, and that's why we have him in the parentheses. Because he's the base ion that's actually causing it to be basic. That's what we did here. This was the acid. His base ion is what actually made it basic. Okay? So here's your hint. Here's your big hints for this problem. So you don't have to go through all this theory and all that. Now that I told you why it is the way it is, here's your hint. So we get to this problem and you go, okay, all right, what am I looking for? So you go through your steps. You're like, what am I looking for? It says, what is the pH? Okay, I'm looking for pH. All right, so then you go, what did they give me? They gave me 1.5 molar of this guy. Okay, I'll just write him out. Gave me the Kb. All right. So then your next step, you go, okay, well, I want pH. So I need to know if this is an acid. If he's a strong acid, I could just plug him in. So you got to figure it out. So your next step is to say, is he an acid, a base, or a salt? That's your next step. Anytime. So it doesn't matter if we're doing that problem, if we're doing like, say, this problem, or the problem before. Okay, if I'm trying to find it, you gotta figure out what it is. So to figure this out, if this is in parentheses, then it's automatically a salt. If there's nothing in parentheses, then it's not a salt, it's an acid or a base, and that's the ones that you have to have in the chart. Okay? And then if it's not in the chart, usually from the name, it'll give you a hint, or you would know from the fact that it would say Ka or Kb. So if it was just Ka, nothing like this, it's an acid. If it's just Kb, none of this, it's a base. If it's either Ka or Kb and there's something in parentheses, it's a salt. So now I know it's a salt. Now I want to know what kind of solution. So since it gives me Kb, I know it's a salt with, so it's not this, it's not this, it's a salt with a basic solution. That's what I need to know. Okay, so I have something in my parentheses, so it tells me it's a salt, and since it's Kb, it's a basic solution that comes from my salt. All right, so I need to find the pH. So since it's a salt, I can't just plug the pH into the pH equation. I have to do an ice table. So then you might say, well, how do I write the ice table? Whatever is in the parentheses, that's the first thing you write. Plus water. It's always that plus water. Okay? I said it's a basic solution. So if it's basic, what's the base ion? OH minus. So he's going to give up the H plus to him to form the OH minus. So he's going to gain the H plus, which would make him HCO3 minus. Okay? So whatever is in parentheses, that's what you write. Always water. Then if this is Kb, he forms the base ion. So then you have to figure out what he would be based on the fact that he's going to give up the H plus to him. All right, ice. What do I have originally? I have 1.5 molar in my salt. He's a liquid, he doesn't count. 0, 0. Negative x plus x. See how it's the same? 1.5 minus x, x, x. Gets really similar. So if I want pH, I don't have H3O plus, but I have OH minus, so I can find pH from the OH minus, kind of like the last problem we did. So I need X. Well, what else did they give me? They gave me Kb. So Kb is the OH minus over the HCO3 minus over the CO3 2 minus. So this is 2.1 times 10 to the negative 4 is equal to X times X over 1.5 minus x. All right, let's simplify. 2.1 times 10 to the negative 4 is equal to x squared over 1.5 minus x. I want to do my approximation. So I need to check that my x is a lot less than 0.1. Okay. I need my Kb to be very small, and I need my percent ionization or ionized to be less than 10%. Those are my rules, right? So I just keep my approximation rules because I want to be able to do my approximation. So let's look. The only one I could do ahead of time is Kb. Kb is 10 to the negative 4. Check. So I could go ahead and assume that I can, ooh, did not mean to press that button. I can ignore that. 2.1 times 10 to the negative 4 is equal to x squared over 1.5. Multiply that over. You get 3.15 times 10 to the negative 4 is equal to x squared. Square root both sides. X is going to be 1.77 times 10 to the negative 2, which is less than 0.1. So we're good there. So now I have x. Okay? So you could also go ahead and find your percent ionized. So percent ionized is x over initial times 100. So that's going to be 1.77 times 10 to the negative 2. The initial was 0.15, or 1.5, sorry. I don't know if I said that wrong or not. So that's going to come out to be 1.18%. So that means that my approximation was good. I didn't have to do the quadratic equation, which is almost always the case. It almost always works. All right, so I have x. Let's go back and go, wait, I just did all this work. What was I trying to figure out? I was trying to figure out the pH. I have x. What is x? X is OH. So if OH, I need H3O plus. So instead of finding pH, let me find POH first. So this is the OH minus concentration. So POH, negative log of my OH minus, which is my x. So plug that in. Get my POH to be 1.75. I want pH. pH plus POH is 14. So my pH is 12.25. And it's got to come out to be some sort of basic number because we said that it has to be a base. So if it doesn't come out as basic, you did something really wrong. The other thing is, this number isn't that bad. So since it's a little bit of a bigger number, it's not like 10 to the negative 6 or 7, then it should be a stronger base. So it's not super small, it's not gonna be like pH of 14, but it should be closer to 14 than like 7. Okay, so I know that's a lot, but that is how to do it if my salt solution is from a base. So if I have a strong base and a weak acid, so strong base, weak acid, my solution is gonna be basic, so my salt is gonna be a basic salt, and then I can find the pH from that. All right, the next we're gonna do is we're gonna flip it. Instead of it being strong base, weak acid, it's gonna be strong acid, weak base. Okay, so we'll just flip it around the other way. So we'll do that problem on the next lecture.